Mercury is the planet that is closer to the Sun. However, this does not necessarily imply that it is always heated. Although temperatures can reach as high as 430 degrees Celsius during the day, they can descend to a frigid minus 180 degrees Celsius at night. Mercury's extremely thin exosphere is responsible for this extreme temperature fluctuation, as it is incapable of regulating heat. Forget about the weather. Instead, prepare for a complete lack of breathable air and intense solar radiation, which is nearly 7 times as intense as what Earth receives. It would be perilous to land on this smallest planet, as it is characterized by craters, mountains, and uneven terrain. The minimal air resistance would render it exceedingly challenging to decelerate a spacecraft, thereby elevating the likelihood of a high-speed collision. The intense heat, which exceeds the capabilities of even the most advanced NASA spacesuits, renders landing during the day impossible. And although a Mercurian day lasts approximately 6 months, the nighttime provides no respite, as the temperatures are significantly below the safety thresholds of current spacesuit technology. In the Terminator zone, the twilight zone between day and night, temperatures are more moderate, although they are still subject to rapid fluctuations. This is your tenuous hope. Venus, the planet closest to Earth at a distance of only 40 million kilometers, provides a relatively brief 4-month voyage. Its size and gravitation are comparable to those of Earth, which presents fewer initial obstacles. Nevertheless, the stunning yellow clouds that beckon your arrival are a lethal trap. They are made up of sulfuric acid, a highly corrosive substance that would immediately incinerate your lungs. Your descent would disclose a significantly reduced visibility as you enter an extremely dense atmosphere composed primarily of carbon dioxide, assuming that a miraculously advanced suit could filter this out. Subsequently, the temperature rises to an insufferable 450 degrees Celsius. The surface is left in darkness, as only a fraction of sunlight penetrates the dense atmosphere, further exacerbating the anguish. Moving would be a challenge, as the dense air would feel like wading through a weighty liquid despite the Earth-like gravity. The overwhelming pressure, which is 92 times that of Earth's sea level, would implode your protection in mere seconds, even if you were wearing a robust pressurized suit. And if that did not kill you, the inescapable fissure that resulted in the inhalation of sulfuric acid certainly would. Mars, the planet that is second nearest to Earth, is frequently regarded as the most habitable of the 8. Daytime temperatures are comparatively mild, with temperatures reaching a comfortable 20 degrees Celsius. The genuine obstacle occurs during the night, or in frigid regions, where temperatures can drop to minus 153 degrees Celsius. Mars has an atmosphere that is incredibly thin, predominantly composed of carbon dioxide with only trace amounts of breathable oxygen, similar to Mercury. This thin atmosphere also leads to dangerously high levels of radiation exposure and low pressure, which are substantially higher than the average on Earth. Additionally, Mars is susceptible to frequent and severe dust cyclones, with winds that can exceed 100 kilometers per hour. A life support system that is extremely sustainable, airtight, and well insulated would be required in order to establish any form of habitation. Its intense radiation fields are the primary reason why Jupiter, the solar system's colossus, presents challenging landing conditions. The radiation would be lethal even at a distance of 300,000 kilometers. Jupiter's gravity, which is 2.4 times stronger than Earth's, would cause you to plummet if you were to wear a hypothetical radiation-proof garment. As you ascend into the upper atmosphere, you will confront frigid white clouds of frozen ammonia crystals with temperatures around minus 150 degrees Celsius and winds reaching insane speeds of up to 482 kilometers per hour. NASA's Galileo probe accomplished the deepest penetration to date, approximately 150 kilometers beneath these uppermost layers. Darkness descends beyond this point, and both temperature and pressure experience a significant increase. The pressure in the vicinity of Jupiter's center is estimated to be approximately 100 million times that of Earth's atmosphere. Before reaching metallic hydrogen, an immensely dense liquid that would ensnare you, you may encounter a supercritical fluid, which is neither liquid nor gas. Temperatures at Jupiter's core, which may or may not be solid, could reach an astonishing 24,000 degrees Celsius, which is several times higher than the surface of the Sun. Saturn, the second largest planet, is home to an atmosphere composed of hydrogen and helium. The initial challenge would be to navigate the 146 moons that orbit the planet. Assuming that you circumvent the cosmic collision course and the debris-filled rings, which are composed of ancient moons, ice pellets, comets, and asteroids, you may approach its equator. Exceptional red and purple auroras, which are the result of energetic hydrogen, are accompanied by hurricane-force winds that reach speeds of approximately 1,800 kilometers per hour, rendering stability virtually impossible. The prospects are not improved by attempting a polar entry. A colossal tempest that is capable of swallowing two Earths is located in the North Pole. Ammonia vapors and temperatures that can plummet to minus 250 degrees Celsius are also present in this region. The temperature would ultimately rise to 0 degrees Celsius as it descended through the cloud layers. Although the cold may diminish, the pressure becomes an overwhelming hazard, reaching levels that are comparable to the deepest ocean trenches on Earth. More deeply, the gases would undergo a transition to a liquid state. If you were to survive the voyage to Saturn's center, you would encounter a molten, rocky core that is approximately 10 times the size of Earth. The pressure in this region is approximately 1,000 times greater than that of Earth, and temperatures can reach a sweltering 11,700 degrees Celsius, which is more than twice the surface temperature of the Sun. The journey is incredibly long, as Uranus signifies the beginning of the genuinely distant planets. Additionally, this ice giant rotates at a rate that surpasses that of Earth, with a day lasting only 17 Earth hours. It is distinguished by its ability to turn on its side. Uranus is not a solid ice ball, despite its icy moniker. It is predominantly composed of heavier elements than hydrogen and helium. Similar to Saturn, it would be necessary to initially avoid its rings. Upon passing them, the temperature would swiftly decrease to below minus 200 degrees Celsius, rendering it the coldest planet in the solar system, and you would be enveloped by toxic gas. Even more severe conditions would await you as you descend through the initial atmospheric layer. If the frigid, cold, and poisonous atmosphere were not enough to harm you, the air would become dense and you would be inundated with ice crystals. Eventually, you may be able to observe the extraordinary phenomenon of diamond rain, which is fueled by winds that can reach as high as 900 kilometers per hour. Nevertheless, you would be crushed by the immense pressure, which is approximately 100 times greater than that of Earth. Neptune, the second ice giant and Uranus's compositional counterpart, is the planet that is the furthest from the Sun, at a distance that is 30 times greater than that of Earth. Consequently, there is perpetual darkness. Neptune's outer layers are exceedingly cold, akin to Uranus. However, its interior layers are exceedingly hot as a result of the immense pressure and heat emanating from its core, which reaches approximately 7,000 degrees Celsius, a temperature that surpasses that of the Sun's surface. It is also subject to the renowned diamond rain, which is produced as a result of the high pressure that breaks down methane. Neptune's winds are among the strongest in the solar system, capable of reaching supersonic velocities. It is similar to Uranus in numerous ways, but it provides minimal additional hospitable conditions.